Hello students, so I am Murugayan and today we are going to discuss electrochemistry part 1. This is very important and chapter, and more number of numericals are expected from this particular chapters for board examination point of view as well as and joint entrance examination and NEET examination. And electrochemistry, actually what is electrochemistry? So electrochemistry is the study of production of electricity from energy released during spontaneous chemical reactions and use of electrical energy to bring about non-spontaneous chemical transformation. So there are 2 points very important. For two purpose we are using and the electrochemistry. The one is the during spontaneous chemical reaction. Look at this. This is spontaneous chemical reaction. The other one, non-spontaneous chemical reaction. So the non-spontaneous chemical reaction with the help of electricity from outside, and from spontaneous chemical reaction we can get some amount of electric energy. So electric energy is produced from and spontaneous chemical reaction, and with the help of electric energy and we can ensure the redox reactions of what kind of redox reaction? Non-spontaneous chemical reactions can be performed with the help of electrical energy and from outside. So based on these two, there are two types of chemical cells. The one is electrochemical cell, the first one electrochemical cell, the second one electrolytic cell. So in this chapter we are going to discuss elaborately about electrochemical cell as well as electrolytic cell. And first we can discuss electrochemical cell. And electrochemical cell is also known as Daniell cell. Daniell cell or voltaic cell. So we have studied the construction and functioning of Daniell cell in 11th standard itself. So this cell converts chemical energy liberated during the redox reaction. So remember, this is a redox reaction. Redox reaction. So during the redox reaction, and Zn, here zinc is oxidized to Zn2 plus, and Cu2 plus is reduced to, this is a reduction. The another pair is oxidation. Oxidation. So both the reduction and oxidation occurred in the single reaction. So this is known as a redox reaction. From the redox reaction we can get a Gibbs free energy. The Gibbs free energy is converted into that is electrical energy. Gibbs free energy denoted by delta G. Is we maintain all the concentration 1 unit mean this is standard Gibbs free energy. From the standard Gibbs free energy, the equivalent amount of an electric energy is obtained. So the electric energy is obtained from the electrochemical cell is always and proportional to and Gibbs free energy. So the energy obtained from the redox reaction converted to electrical energy and has an electrical potential equal to 1.1 volt when the concentration of Zn2 plus and Cu2 plus ion is unity, the 1 molarity, 1 mole per decimeter cube, then the 1.1 voltage is nothing but standard and cell potential containing the redox reaction between zinc and copper at 1 unit concentration is known as an galvanic or voltaic cell. Galvanic or voltaic cell. Okay. Now, to get exact pictures about electrochemical cells, look at this. In the electrochemical cell, there are two vessels, the left side vessel and right side vessel. Within the vessel and one electrode. This is electrode. This is electrode. One electrode. This electrode is another electrode. So the right side electrode is made of the metal copper. The left side electrode is made of the metal zinc. Externally, the two electrodes are connected by conducting wire. Okay, and the two left side electrode and vessel containing electrolytic solution of the metal. The metal, what metal we are using on the left side electrode? Zinc. So the electrolyte is and salt of zinc. For example, zinc sulfate we can use. The solution containing the salt of zinc can be zinc sulfate, ZnSO4. And similarly, on the right side vessel and including the electrolytic solution of copper, that is copper sulfate and copper electrode, is generally known as half cell. So this is right half cell. The other one is left half cell. So to ensure the connectivity or ensure the closed circuit, the two vessels are connected by one connecting bridge with inert salt. So this is salt bridge. The salt stuffed within this will not react with the zinc and copper. Okay, so just for the connectivity purpose, so this is known as salt bridge. And listen here, the left side electrode zinc is given negative sign. So this is negative electrode. This is negative electrode. The other one is positive electrode. The positive electrode is known as cathode. The negative electrode is known as anode. So from anode, the electron moves in this direction. This is the direction of electron. Opposite the direction of electron, conventional direction of current. So the current direction is nothing but and direction of electric field. Opposite to the direction of electric field, the electron moves. So what is happening in the, this is actually electrochemical cell. Electrochemical cell. The electrochemical cell, the negative, this anode, oxidation occurred. Oxidation on anode, reduction on cathode. On positive electrode side, reduction occurred. And negative, so this is a pure zinc. It dissolved into the solution in the form of Zn2 plus and Cu2 plus as electrolytes. After reduce, it deposit over the electrode as pure form of Cu. Okay, this is a net reaction, and through this the salt bridge accept only SO2 sulfate, SO4 minus 2 minus. Due to the migration of the SO4 2 minus, then the electric circuit completes. So this is a brief discussion about electrochemical cell. Electrolytic cell, the opposite way. So if it is a standard cell, what is the potential of the standard cell? 1.1 voltage. 1.1 voltage. If you maintain the concentration of Cu2 plus as well as Zn2 plus 1 capital M, the molarity, 1 molarity, then this is known as galvanic cell or voltaic cell with the 1.1 voltage. The same things discussed in the previous page. Okay, so the discussion, the continuations of the previous page alone. If an external opposite potential is applied from outside, if an external potential applied from externally outside in the galvanic cell, what is happening? The external voltage gradually increased. We find that the reaction continues to take place. Even though some amount of external voltage applied to the cell, the redox reaction, that is a spontaneous redox reaction, continues until the external voltage given to the cell reaches 1.1 voltage. What is 1.1 voltage? 1.1 voltage is a voltage obtained from standard electrochemical cell. So in the external voltage is less than 1.1 voltage, the spontaneous redox reaction continues. Once the external voltage reaches 1.1 voltage, then they balance each other. There is no migration of electron from anode towards cathode. So in the circuit there is no current. So this is dead state, dead position. And if you increase further the electrode potential, if the electrode potential, that is external potential, is greater than 1.1 voltage, now with the help of this, the current direction reverse but within the cell, and we can ensure the non-spontaneous redox reaction. To perform non-spontaneous redox reaction within the cell, and we should give external potential more than 1.1 voltage. So this is a thing is given in this paragraph. When the reaction stops altogether and no current flows through the cell, any further increase in the external potential again start the reaction, look at, in opposite direction. In this is opposite direction. It now functions as electrolytic cell. Listen, for electrolytic cell, what is the condition? External voltage. External voltage should be given, and it should be more than 1.1 voltage. Then electrochemical cell is converted into electrolytic cell. Electrolytic cell is converted into electrolytic cell. In the electrolytic cell, non-spontaneous redox reaction. In electrochemical cell, spontaneous redox reaction occur. So these are the points to be remembered. Okay, to understand this, look at the first diagram. This is actually external voltage is given, but external voltage is less than 1.1 voltage. Look at this. the external voltage is less than 1.1 voltage, so the spontaneous reaction continues. Inside the spontaneous reaction Zn into Zn2 plus and Cu2 plus and settle over the and cathode surface and Cu and pure state. So the current electron travel from anode, this is anode, electron travel from anode to cathode. Still the spontaneous reaction occurred, and still we are able to get current from the cell whenever the external potential is less than 1.1 voltage. When the external potential is 1.1 voltage, and there is no conversion, everything stopped, no oxidation reaction and no redox reaction. Here there is no electron is not moving, there is no migration. And what is the potential difference between and the two electrodes? Zero. Potential difference zero mean and zero current. So at this stage the external potential equal to 1.1 voltage mean the cells become dead, so it won't function at all. There won't be any redox reaction within the electrode vessel, either left side vessel or right side vessel. In both the half cell, reduction reaction or oxidation reaction will not occur. So in case the external voltage is more than, look at here, the external voltage is more than 1.1, the direction of current reverse. Now previously the zinc electrode was anode, now cathode, so negative electrode become positive, so right side now positive, left side now negative. So the previously the copper electrode was called cathode. When the external voltage is more than 1.1 volt, becomes anode. Anode means negatively charged. So in the anode here oxidation occurred, on right side oxidation occurred, the left side reduction occurred. So electron direction from right side to left side, current direction from left side to right side, totally direction of current reverse. So this particular cell is known as electrolytic cell. This is electrolytic cell. What is the condition of electrolytic cell? The external voltage is greater than 1.1 volts. Very important. So here what kind of reactions occurred? Non-spontaneous reaction occurred. Non-spontaneous reaction occurred. So non-spontaneous reaction means the Gibbs free energy is positive, not negative. Here delta G is positive. Okay, that and all we discuss elaborately later. Understood? And we'll move further. Now again the detailed discussion around the galvanic cell. What is another name of galvanic cell? Voltaic cell. A galvanic cell is an electrochemical cell, that is current producing cell by means of redox reaction. And what kind of redox reaction? Spontaneous redox reaction. A galvanic cell is an electrochemical cell that converts the chemical energy of a spontaneous redox reaction into electrical energy. This is the role of the galvanic cell. So it converts the spontaneous redox reaction into electrical energy. In this device, the Gibbs energy of spontaneous redox reaction is converted We had already discussed this point. The Gibbs free energy. What is Gibbs energy? Delta G is nothing but delta H minus S into delta T from thermodynamics. If it is standard, mean all the delta H will be standard enthalpy. Okay. So the Gibbs energy of the spontaneous redox reaction is converted into electrical work, which may be used for running motor or other electrical gadgets like heater, fan, geyser. Okay. Now, on further discussion, a Daniell cell. We had earlierly discussed Daniell cell. The Daniell cell also a kind of electrochemical cell. So the Daniell cell, usually listen, the Daniell cell mean, and we should follow certain characters. There we are using only zinc electrode and copper electrode. So wherever in any cell, if we use zinc electrode and copper electrode to bring electrical energy by means of spontaneous redox reaction between the couple Zn and Cu, the cell is known as Daniell cell. What is the maximum amount of voltage obtained from the Daniell cell? 1.1 voltage. These are the basic information about the Daniell cell. Okay. So dear student, you have to remember all this point. So the Daniell cell is discussed earlier, is one such cell in which the following redox reaction occurs. Zn is oxidized to Zn2 plus and Cu2 plus is reduced to Cu in pure form, and the suffix Aq mean aqueous. So hydrated, aqueous mean hydrated ion, hydrated electrolyte. Hydrated ion is known as electrolytes. Only hydrated ions, electrolytes are charge carriers. Very important. So this reaction is a combination of two half reaction. In one half reaction, oxidation reaction, and another half reaction and reduction reaction occurs. So we have discussed, and copper 2 plus aqueous state electrolytes is reduced to pure form of copper by means of reduction reaction. So on right side of the electrochemical cell, reduction occurred, on left side oxidation occurs. So the reduction half reaction is Cu2 plus accepting 2 electrons and become and pure state of Cus. So this is reduction, accepting 2 electron. This is a pure state, and oxidation, losing 2 electron, and zinc becomes Zn2 plus. After hydration, Zn2 plus become aqueous. Only the aqueous Zn2 plus is known as electrolyte. This is electrolyte, but this is not electrolyte. These are not electrolyte. Only hydrated ions are known as electrolytes, or molten form of or solvated ions are electrolytes. So one couple is known as reduction half reaction, the other one is oxidation half reaction. Then the combined couple is known as redox couple. The redox couple can be separated into two half reaction to mean reduction and oxidation. Reduction conventionally occurred on the right side electrode, oxidation on left side electrode, and oxidations, out of oxidation the electrode become negatively charged, and cathode, that is reduction electrode, become positively. Okay, we'll continue. So these reactions occur in two different portions of Daniell cell, and the reduction half reaction occurs on the copper electrode, while the oxidation half reaction occurs on the zinc electrode. What we have discussed, everything is given in this paragraph. Now construction of Daniell cell. How to construct a Daniell cell. Okay, so we can construct a good number of galvanic cell on the pattern of a Daniell cell by taking combination of different half cells. Each half cell consists of a metallic electrode and dipped into an electrolyte. What is electrolyte? The salt of the particular metal. So if we use zinc is the electrode mean, and zinc salt is used as electrolytes in the particular vessel known as a half cell. So the two half cells are connected by a metallic wire through a voltmeter is known as, which externally is known as salt bridge, and the two half cells are connected by a metallic wire through the voltmeter, that is external circuit, and switch externally, and the electrolytes of two half cells are connected by two electrodes are connected by wire and voltmeter, and two electrolytes of the two different half cells are connected by internally through a salt bridge. This is very important, and the salt bridge connect two electrolytes of the vessel, and two electrodes are connected by a conducting wire externally, so that the electric circuit becomes complete. Otherwise the circuit will be open circuit, so there won't be any current in the cell. We cannot give to the current to the cell, or we cannot extract any amount of current from the cell by means of spontaneous redox reaction. So sometimes both electrodes dip in the same electrolyte. In some other situation, in the same vessel, and two electrodes are dipped. This a negative electrode, this is positive electrode. These electrolytes, common electrolytes are used to mean this external. So in this case, which is not required, and no salt bridge. So whenever we are maintaining the half cell separately, and left side half cell, right side half cell with only one electrode, this also only one electrode, then to connect the electrodes we have to connect one salt bridge. We have to connect one salt bridge externally along with the current measuring voltmeter. So this is cell with a two half cell, this is cell with a single vessel. In case of single vessel, salt bridge is not required, but this is salt bridge. Remember to write and cell reaction, the two half cells are separated by a two vertical line. If we follow the two vertical line on the left side of two vertical line, oxidation half cell, on the right side of two vertical line, reduction half cell should be written in proper conversion method. So continue. And each electrode electrolyte interface, and there is a tendency of metal ion and from the solution to deposit on the metal electrode, trying to make it positively charged on the cathode. At the same time, metal atoms of electrode have the tendency to go into the solution as ion and leave behind electron at the electrode, trying to make it negatively charged. This is occurred on anode, the other one on cathode. On cathode, and the electrode become positively charged, and anode, the electrode became negatively charged due to accumulation of electrons and due to oxidation occurred. So some part of the metals of anode dissolve into electrode after oxidation. Zn become Zn2 plus, the leaving 2 electron there itself. That's why the electrode becomes more negative. So electron travel from a negatively charged electrode towards positively charged electrodes. The negatively charged electrode is known as anode conventionally, and positively charged electrode is known as cathode. So very important. And a potential difference developed between the electrode and electrolytes. Listen, the potential difference between any point on the electrode and any point within the electrolytes very close to the electrode is known as electrode potential. This definition is very, very important. Once again go through. A potential difference develops between electrode and electrolytes, which is called electrode potential, and where the point within the electrolyte should be taken, the point should be very close to the electrode you have selected. The electrode can be negatively charged electrode or positively charged electrode. If you select a negatively charged electrode, this is electrode potential of anode. If you select positively charged potential electrode, that is positive charge of this electrode potential of cathode. That's all. When the concentration of all these species involved in the half cell is maintained 1 unit molarity, the cell potential or electrode potential is known as standard electrode potential. So the standard electrode potential, E electrode potential, to mean standard superscript 0 and suffix put L or R. L mean left side standard electrode potential, that is oxidation standard electrode potential, and E suffix R mean right side superscript 0 mean this is standard reduction potential, this is standard oxidation potential. So dear student, and conventionally according to IUPAC system, we are measuring and the electrode potential as a standard reduction electrode potential. So according to IUPAC convention, the standard reduction potentials are now called standard electrode potential. So the standard electrode potential positive mean is favor reduction reaction. The standard electrode potential is negative mean it favors oxidation reaction. So in the galvanic cell, the half cell in which oxidation takes place called anode, and it has negative potential with respect to the solution. The other half cell in which reduction takes place is called cathode, and it has positive potential with respect to the solution. We had already discussed. So there exists a potential difference between the two electrodes. As soon as the switch is in the on position, then electron flow from negatively charged cathode towards positively charged and electrode, that is called cathode. So the electron travel from anode to cathode, current direction from cathode to anode. So always the direction of electron and direction of electric field is opposite direction. So the direction of current flow is opposite to that of electron flow. Okay, we'll continue. Now we are entering another important area, and cell potential and representation of potential. Actually we had detailed discussed half cell potential. The half cell potential is nothing but electrode potential. There are two electrode potential, and the electrode potential on the right side is known as E right side, or simply we can use R. This is, we can put right side. There is no zero mark in the superscript. This is not standard electrode potential. Simply electrode potential of right side mean, and oxidation right side mean this is reduction potential. Reduction potential. And E left side conventionally is nothing but E suffix L is oxidation potential. And to get the cell potential positive, in order to get an E cell as positive, then the left side oxidation potential is separated always from reduction potential, because reduction potential always positive, oxidation potential negative. When you subtract a negative potential from positive potential, the overall potential can be 0. So this is the reason we are following the conventional method, and in evaluating cell potential, and we have to subtract left side electrode potential from right side electrode potential, or in the other way, from reduction potential oxidation potential should be subtracted. Very, very important. Okay, we are going to apply what we have discussed earlier with the help of one example. So this is illustrated by the following example. In the example, the cell reaction given, copper in pure solid and 2 mole of silver electrolyte, that is aqueous Ag plus, this is electrolytes, and Cu2 plus and Cu after Cu becomes Cu2 plus after oxidation. This is oxidation. Ag plus is reduced to pure form of silver on cathode. This is reduction. Here totally reverse. But when we use the couple Zn and copper, copper is reduced, Zn is oxidized. But here we are using other kind of couple. What are the two couples? First we have to write always, and reduction couple, or conventionally we can use copper is oxidized Cu and silver is reduced Ag. This is known as couple, that is cell couple. And previously when we use zinc and copper, first zinc is oxidized and copper is reduced. Comparing these two, the reduction potential of copper is more than that of zinc, but here the reduction potential of silver is more than that of copper. So these are the point to be noted in constructing and cell reaction. Okay, so what are the half cell reaction related to the given and redox reaction? This is known as redox reaction. Why? In the same time, oxidation reaction as well as reduction reaction occurred. In the reaction, we have shown electrolytes. What are the electrolytes here? Ag plus aqueous one electrolytes. In these electrolytes is deposited on the cathode accepting electrons, and Cu2 plus is entered from pure form of copper electrode with the help of or by means of oxidation reaction. On the cathode, and 2 molecules or 2 moles of Ag plus electrolyte accepting 2 mole of electron and becomes a pure form of silver, a deposit on the cathode. So this reaction is known as cathode reaction or half cell reduction reaction. The other one, half cell oxidation reaction. Here copper in pure form dissolve into the electrolytes, losing 2 electron to its standard oxidation state Cu2 plus. The Cu2 plus is not electrolyte. The only hydrated Cu2 plus is known as electrolytes. So it can be seen that the sum of the two reactions 1 and 2 leads to overall cell reaction in the cell, and the silver electrode act as cathode and copper electrode act as anode. This is understood from our elaborate discussion. On the basis of the elaborate discussion, then how to write the cell reaction represented, and by for the redox reaction, the writing cell reaction is very, very important. Writing this is cell reaction, not redox reaction, cell reaction. In the cell reaction, we have to start always from oxidation first, then separation to a parallel vertical line, and right side reduction. Okay, so here which is oxidized? Copper is oxidized mean, and we have to take copper. This is electrode. This is electrode, and pure form losing 2 electron. It is oxidized to Cu2 plus. This is oxidation. The first left side oxidation. It is become hydrated Cu2 plus electrolyte. Then this is left half cell. That is oxidation half cell. is separated by, this is separation, salt bridge, then Ag plus this electrolytes after reduction deposit over the silver electrode in its pure form. This is a reduction. So in cell reaction, left side oxidation, right side reduction, in between salt bridge. But to compute cell potential, we have to reverse the direction. First, electrode potential of and reduction electrode potential minus oxidation potential. Reduction potential minus oxidation potential is cell potential. I will write once again, cell potential, CE, cell potential is equal to reduction potential minus oxidation potential. It's very important. But to write cell representation, first oxidation, the second one reduction, and separated by, this is salt bridge. Salt bridge. Okay? Make note all these points. Now, how to measure an electrode potential? If you want to measure potential of particular electrode, and this is not possible. So we have discussed earlier, the cell potential is combination of cell potential is always difference of reduction potential and oxidation potential, or reduction potential and cathode potential and anode potential. So we need two electrode or two half cell. We required two half cell. So with the help of single half cell, remember, we cannot measure its corresponding electrode potential. For that purpose, and we have to keep one dummy electrode within the cell. The dummy, what is the meaning of the dummy electrode? The electrode potential of the dummy electrode is maintained as 0. The electrode potential is 0. Electrode potential is maintained as 0 is known as dummy potential. For this purpose, we are using and standard hydrogen electrode potential, SHE, or normal hydrogen, standard hydrogen electrode potential, or sometime normal hydrogen electrode potential. So the standard hydrogen electrode potential or normal hydrogen electrode potential equal to 0 volts. Okay, how to consider what is the net reaction in the standard hydrogen electrode or normal hydrogen electrode? The what is He plus? Oxidized form of hydrogen. Oxidized form of hydrogen is He plus. Losing electron, it becomes proton. This is He plus aqueous. This is electrolytes. Is okay, and on accepting one electron, it is reduced to and pure form of, that is what is the elemental form of hydrogen. The elemental form of hydrogen, H2, it converted into half molecules of or 1 mole of H plus, accepting 1 mole of electron give half mole of hydrogen gas, and both are maintained in the electrode 1 unit. So this is the pressure of hydrogen is maintained 1 bar, and concentration of H plus is maintained 1 molarity. The concentration of H plus is maintained 1 molarity. The concentration of H2 gas is maintained 1 bar. Both are in 1 unit, mean what is electrode potential? and electrode potential is maintained as 0. So it's become dummy electrode. So with the help of a C electrode, and we can find the electrode of whatever metal you want to evaluate. This is the great advantage of the construction of and the standard hydrogen electrode. This applications also we are going to discuss in detail. Okay, this is standard hydrogen electrode. Look at the vessel. In the vessel and inside the tube, the standard hydrogen electrode consists of platinum electrode. This is platinum electrode and coated with platinum black. The electrode is dipped partially in the acidic solution. What is inside? This is acidic solution. This is acidic solution. Because of acidic solution, what is the concentration of H plus aqueous? 1 mole, 1.00, not mole, molarity. This is concentration, and inside hydrogen gas is bubbled into the acidic solution with 1 bar pressure. This is inside. So the H2 is converted into H plus, or H plus is converted into H2. So this is a thing is going on, and what is maintaining electrode potential 0. So this is standard hydrogen potential. So the electrode is dipped in an acidic solution and pure hydrogen gas is bubbled through it. The concentration of both the reduced and oxidized, what is the reduced form? 1/2 H2 is the reduced form, and oxidized form H plus, both are maintained at 1 unit. One is 1 bar, the other one is 1 molarity. So this implies that the pressure of hydrogen gas is 1 bar and the concentration of hydrogen ion in the solution is 1 molar. Okay, then because of this, listen what is happening here, and this is the whole thing at 298. Okay, now we are discussing one cell with the left side C, that is standard electrode, the other side and what electrode? The electrode is fixed on the right side, its and standard reduction potential to be evaluated. So at 298 Kelvin, the EMF of the cell is a standard hydrogen electrode and left side, and right side second half cell constructed by taking the standard hydrogen electrode as anode. How to construct? Listen, this is left side vessel, this is the right side vessel, and these two are connected by salt bridge. This is C, standard hydrogen electrode, and this is a copper Cu. So to be evaluated, which has to be evaluated? Electrode potential. Electrode potential. Okay, so this is platinum and this is copper, this is salt bridge. So this is the way we have to construct one cell always, and left side hydrogen, and on the left side SHE, on the right side another half cell. H is nothing but half cell. HCA, a half cell is constructed. Okay. Okay. So, and gives the reduction potential of the other half cell. If the concentration of the oxidized and reduced form of the species in the right hand side are unity, then the cell potential is known as standard potential. So on the right side also, if we maintain the concentration unity, mean what is the right side electrode potential is known as standard electrode potential, is known as standard electrode potential of the given half cell. So this is the general formula. Standard cell potential equal to a right side electrode potential, that is reduction electrode potential, minus left side electrode potential, that is oxidation electrode potential. Here oxidation occur H2 gas, that is H plus, H2 gas is oxidized to H plus. So this value will be equal to 0 for standard hydrogen electrode C. So look at here, EL will be 0 and ER. So the standard reduction potential of electrode is equal to the standard cell potential. Because of the dummy half cell, we are maintaining SHE, standard hydrogen cell, as a dummy electrode because of 0 electrode potential. Now we can write the measured EMF of the cell. Left side oxidation, where oxidation occurred on SHE, that is hydrogen electrode, platinum surface, on the platinum surface, and provide its surface for oxidation reaction and on hydrogen gas. So the hydrogen gas is in the gaseous form, maintained at 1 bar concentration. It is oxidized to H plus with maintaining 1 molarity. This is and SHE, left side oxidation cell, and separation to a vertical line to mean salt bridge on the other side, and copper 2 plus after reduction and deposit as in the pure form to give the electrode potential or cell potential. Here electrode potential is as same as cell potential, 0.34 voltage. So what is electrode potential of Cu2 plus 0.34 voltage? Remember, whenever the electrode potential is positive, the reduction reaction is more favored. The reduction reaction is more favored mean is reduced easily, mean then copper becomes excellent oxidizing agent. Very important. The reduction potential positive mean the particular species become and good reduction, that is oxidizing agent. And with the help of the SHE, with the help of the standard oxidizing standard hydrogen and electrode, we can try to evaluate the potential of Zn metal. So we'll continue our discussion. Listen, similarly the measured EMF of the cell, platinum, hydrogen and H plus, this is SHE. The other side Zn 2 plus is oxidized to this reduced to Zn in the pure form and give minus 0.76 voltage. What is standard electrode potential of zinc? Negative. Remember, very important. The reduction potential of zinc negative mean it shows the least favor for reduction reaction instead of reduction reaction, and the zinc is favored for oxidation reaction. So and whenever we have the two metal Zn and copper, copper in favor of reduction reaction, zinc in favor of oxidation reaction. So in this couple, and we have to keep based on the experiment delta Zn as anode for oxidation and copper for cathode and to perform reduction reaction. So the zinc cathode should be kept on the left side as anode, and copper cathode should be kept on the right side as a cathode, and so that we can get cell potential positive. So we have to subtract minus 0.76 from and 0.36, the cell potential 1.1 voltage can be obtained. So we have concluded left electrode zinc on oxidation, right electrode copper on reduction. So if we continue, listen, what is the cell potential? ER, right side potential or reduction potential minus oxidation potential. 0.34 voltage is the reduction potential of copper, and minus 0.76 voltage is reduction potential of anode. So actually it is favored for oxidation. So minus of minus 0.76 nothing but oxidation potential of Zn is adding both, we can get 1.110. This is the expected value from standard Daniell cell. In the standard Daniell cell we are using zinc as anode and copper as cathode. In order to get the cell potential 1.1, standard cell potential 1.1 voltage, maintaining the and concentration of Zn 2 plus as well as Cu2 plus 1 molarity. Okay, the hydrogen electrode will give 0. What is happening in the hydrogen electrode mean, with the half cell reaction He plus accepting electron becomes no H2. This is known as reduction. He plus is reduced to H2G. And bromine electrode, in the bromine electrode on the surface of the platinum, and half molecules or half mole of and bromine gas aqueous solvated, accepting one electron become bromide ion. So this value 0 for hydrogen and bromine. So with respect to these two, and we can decide, and with respect to the electrode potential of hydrogen, other electrode potential positive mean the positive is favor for reduction. When we compare hydrogen electrode potential, the electrode potential other one of negative mean hydrogen potential favor for and reduction, the other potential favored for oxidation. This is next level and discussion to get more and clarity about the electrochemistry, especially and Daniell cell or electrochemical cell. The same thing is given in this paragraph. So the standard electrode potentials are very important, and we can extract a lot of useful information from them. The values of standard electrode potential for some standard half cell reduction reactions are given in the next page. We are going to discuss in the next class. The table number 3.1, it is available in the NCERT book. If the standard electrode potential of the electrode is greater than 0, it is favorable for reduction. Then its reduced form is more stable. The reduced form is more stable means it is favors reduction reaction. At the same time, it is excellent oxidizing agent. Very, very important. Compared to hydrogen gas. This is the interpretation. Similarly, if the standard electrode potential is negative, then hydrogen gas is more stable than the reduced form of the species. Which is more stable? Hydrogen is more stable. So the hydrogen gas is more stable than reduced form of the species mean. So the given species and favor only self oxidation mean. Self oxidation mean it becomes excellent reducing agent. So the reduction potential negative mean it becomes reducing agent. The reduction potential positive mean it becomes oxidizing agent. So this is the information, this is the idea, a concept extracted from this paragraph. So it can be seen that the standard electrode potential for fluorine is highest in the table. So F2 has a maximum tendency to get reduced to fluoride. So the tendency get fluoride. The fluorine becomes fluoride, so accepting electron, and therefore because of this it is an excellent oxidizing agent. Therefore fluorine gas is the strongest oxidizing agent and fluoride ion is the weakest reducing agent according to chemistry. So lithium has the lowest electrode potential, indicating lithium ion is the weakest oxidizing agent, while the lithium metal is and most powerful reducing agent in the aqueous solution. it may seem that as we go from the top to the bottom of the table available in 3.1, you can see the table available in the NCERT book. So the standard electrode potential decreases, and with this decrease the oxidizing power of the species on the left, and increases the introducing power of the species on the right hand side of the reaction. So electrochemical cells are extensively used for determining the pH value. With the help of the pH value, we can decide the strength of the acidity. The pH value less than 7 means strong acid, more than 7 means weak acid. So based, and as well as not only the acidic characters, the solubility product and equilibrium constant and other thermodynamic properties, all these can be estimated, and we can get clear-cut ideas with the help of the function of the electrolytes, knowing the nature of the electrode, which is whether it is suitable for reduction reaction or oxidation reaction, all based on standard reduction potential. So my dear student, and we have completed with this first class of electrochemistry. Then the continuation in the name of science class will be continued. And thank you student for staying with me to watch my class, and thank you once again.